Okay. Good evening, everyone. My name is Chandan Kumar Gupta. I am a research scholar in Department of Mathematics, IIT Patna. I am your PMRF NPTEL TA. This course is Probability and Statistics, and it is offered by Professor Somesh Kumar. He is a faculty in Department of Mathematics, IIT Kharagpur. Okay. Now let me share my screen. Just wait. Okay. Can anyone confirm? Is my screen visible?
Yes, sir.
Okay, thank you. Okay, then this is the fourth week of the 12-week course of probability and statistics. Anyone wants any question? Ask. If you want to ask any question regarding the previous weeks, you may ask. Otherwise, we will start for week 4 question.
No, sir, you can start the lecture.
Okay, then. Okay. Now in lecture 4, week 4 courses, maybe you people have already watched the lectures provided by NPTEL. Mainly, there are the following topics that are mainly discussed, like Poisson distribution, spatial discrete distributions, and then like uniform distribution, exponential, Weibull, gamma, beta. These are the continuous distribution, which is mainly taught in week 4. We will going to discuss about the distributions, and after that we will solve the questions regarding the related to these distributions. Okay. Now, okay, if want to ask anything, or if you do not understand anything, you may ask directly. Okay, so let's start from the first one is like Poisson distribution. Okay, Poisson distribution is a discrete distribution actually. Okay, and the PDF is written like this. Okay, it is a discrete distribution, e to the power minus lambda, lambda to the power x upon x factorial. And the here lambda is the only parameter. This distribution is mainly used when we are this distribution is mainly used when we are dealing with the discrete random variable, and we are given a rate. Suppose we are dealing with the there we need to calculate the rate, then this distribution is mainly used. The PDF of this distribution is this, and we will try to like memorize the first, second, third, and fourth moments, or we can say that like we need to remember about the mean. The mean for the Poisson distribution is lambda. The variance is also lambda. Even for Poisson distribution, the third central moment is also lambda. Okay, and now also for for measure of skewness, theta 1, which is equal to mu3 square upon mu2 cube. And this is about what? Lambda square upon, which is always greater than 0. Okay, that is okay. That is Poisson distribution is always positively skewed. Okay, and also like beta 2, which is equal to mu4 upon mu2 square minus 3, which is equal to actually, it is also comes out to be 1 by lambda. That means it is also greater than 0. This implies it is leptocoating, getting peaked than the normal distribution. Okay, or like MGF of this is like MGF of this is lambda, and then sorry, it's e to the power lambda e to the power t minus and like one more thing okay, here the random variable is a positive random variable. Like suppose if xi's are independent Poisson variate, if it's a kind of theorem, or you may say that anything, like if xi's are Poisson random variable with lambda I, then in that case summation of xi is also Poisson with the parameter summation of lambda I. This is one of the property of Poisson distribution actually. Okay, and its converse is also true. Okay, but the difference of two Poisson variate may not be a Poisson variate. Okay, and it is always non-negative actually. Okay, now from this is the from here on we will discuss about the spatial continuous distribution. Okay. Now spatial continuous distribution, the first one is uniform. Okay. Okay. The PDF of this distribution is 1 upon b minus a if x belongs to AB, and the expected value, like the first, that mean is b plus a upon 2. Variance for the uniform distribution is b minus a whole square upon 12. Okay, and then its mxt is like e to the power t minus e to the power at upon t b minus a. Actually, we need to learn these things because when we are dealing with different kinds of problems related to distribution functions, then we must know about the PDF. Then we can calculate the expected value of x, variance of x, moment generating function, its skewness and kurtosis, and many other things. Okay, like besides uniform, then the second one is like exponential distribution. Okay. The PDF for the exponential distribution is, okay, lambda e to the power minus lambda x, where x is greater than 0 and lambda is greater than 0. Okay, its CDF may be written as, can anyone tell me like where we use exponential distribution, or where we use these type of distribution actually? Okay, like suppose when we are dealing with the lifetime of when we are dealing with the lifetime of suppose electronic component like bulb. Okay, so the data shows that the lifetime of the bulbs follows the exponential distribution actually. Okay, so we can model the lifetime with the help of this distribution. Then we can calculate the parameter, and then we can calculate the reliability, hazard rate, and the probability after a certain time period, whether that company bulb is good or not. These, that is why we need to learn about these distributions actually. So we mainly know about the PDF, the expectation of x, that is expected value. What is expected value? It is 1 by lambda, and variance in case of exponential distribution is 1 by lambda square. Okay, and also it is actually positively skewed distribution. That is, beta is always greater than 0 for this. Positively skewed. Okay. Similarly, like gamma distribution.
Sir, what is the MGF of exponential distribution?
Okay, MGF. Okay, okay. Let me check actually. Okay, the MGF. MGF is defined as like this, na, expected value of e to the power tx. Okay, so it can be calculated as like it's 1 minus lambda t here. Okay, 1 minus lambda t power 1, or 1 upon 1 minus lambda t. Okay, actually these like all these things are already covered in the lectures, na? So that's why I've just tried to recap these things, uh, and then we will solve questions related to these distributions. Okay. Anything else?
No, sir. Thank you.
Okay. Okay. Then gamma distribution, like the PDF for the gamma distribution is, okay. It's, suppose it's beta to the power alpha upon gamma alpha, e to the power minus beta x, x to the power alpha minus 1, here x greater than 0, alpha is greater than 0, beta greater than 0. Okay, so this is the PDF for gamma distribution. Also, for gamma variate, like expected value is alpha upon beta, and variance of gamma variate is, it's alpha upon beta square. Okay, this is the, actually this is very important distribution. Like it is a lifetime distribution which is mainly used to fit different lifetime data. Okay. Again, besides this, there is beta distribution, I think. Yes. Okay, beta distribution. Okay, this is the beta distributions, and for the beta distribution again, mean equals to m upon m plus n, and variance equal to like mn upon m plus n square, m plus n plus 1. Here m and n are the parameters of the beta distribution. Okay, these are just for recap, like we will going to use these distribution in our question. Okay, any other distribution? Let me check gamma, beta. Okay, like we may also use the shifted exponential distribution. Suppose x follows shifted exponential, then the PDF is 1 by sigma e to the power minus of x minus mu upon sigma. Here again, mu belongs to real number, sigma is greater than 0, and x is greater than mu. Okay. Now, expected value in this case is mu plus sigma, and variance is sigma square. Okay. Now, beside this, yes, there are two more concepts actually. Like the first one is reliability. These all are the topic. Yes.
Is there any Laplace distribution?
Yes, there are different distributions. Actually, just I am trying to recall some. Sir has already taught different forms of distribution with their mean and variance and like skewness and kurtosis. There is a Laplace distribution. Hello.
I have one doubt, sir, regarding that distributions.
Yes, you may ask.
Hello.
Yes.
What is the memoryless property of that distributions?
Okay, memoryless property. Yes. Like memoryless means what?
Commentary distribution.
Your
Is
voice
that
is
memory?
Your voice is something broken. Like, try to ask again.
Is what is the memoryless property distribution?
Okay, memoryless property of a distribution. Okay. Actually, we have a question already on that topic. Okay, I can write here actually. Like even last time we will discuss about the memoryless property. Like suppose we need to find the probability for x, a random variable x, which follows some distribution first. Okay, there are mainly two distribution that follows memoryless property. Okay, the one is last time we have discussed about, it is a geometric distribution, and exponential distribution also follows memoryless property. Okay, so what it means, like when x greater than, we need to calculate the probability for a random variable x which is greater than m plus n, given that x is already greater than n. Okay, that means ki, like the property, suppose the event we are going to evaluate, is not happen up to point T. Okay, then what is the probability that it will happen or not happen till point m plus n? Then it can be same as probability that x is greater than m. This is the memoryless property. The waiting time and the okay, I'll give you the statement. I have already written actually, but we are written. Yes, like suppose a random variable share in exponential distribution, then this property holds, then it is called memoryless property actually. The waiting time and the additional time both follow the same distribution, and suppose we need to calculate this probability, then we can use this property and calculate this. Both have the same values or same probability. This is actually memoryless, and it is mainly followed by geometric in case of discrete and exponential in case of continuous. Okay. Anything else?
For beta distribution and gamma distribution, not follow the memoryless properties.
No, no, it is not followed. It is actually just for this purpose. No, you may, for verification purpose, you may try to solve this, the value of probability this for beta or gamma. Okay. And then evaluate this value. Both are not same.
Okay. But one of the question they will ask which of the properties memoryless, Laplace, gamma, beta, uniform.
Yes, yes, yes. I think you forgot something. You forgot to mention something like gamma with some parameter.
Shape parameter equal to 1. Alpha value is given.
Yes, that is why. No? Because all, like suppose when we will just suppose x, a random variable, follows some distribution. Okay. And then under certain assumption or certain restriction, the same variable converted to another, like follows another distribution, means all distributions are connected to each other na? Under some assumptions or some conditions, like for gamma. Okay, I think I forgot to mention. Okay, gamma na here. Suppose we have considered beta and gamma equal to 1, then what we found? At alpha equal to 1 and beta equal to 1. Then that means it's this, which is exponential 1. Okay. So that means gamma distribution tended to exponential distribution. Gamma tended to exponential when alpha equal to 1, beta equal to 1. Okay, so gamma distribution now converted to exponential, and we have read that na, like exponential distribution follows memoryless property. So this is the case. Is it clear?
Okay, sir.
Okay, like also
Yeah.
yes, yes. You may also like maybe recall, like suppose x follows binomial NP. Okay, then if here there are two parameters for binomial. If p tends to 0 and n tends to infinity, that is n is large and p is very small, then in that case the same variable tended to Poisson distribution. Okay, so now binomial converted to Poisson. Okay, tended to Poisson distribution. So all distribution are likely related to each other. Okay. So similarly, different like chi-square distribution is also there, which is also related to exponential distribution. Okay. Okay, now reliability. I'm just trying to recall some of the topics that sir has already covered in the week 4 lecture. Okay, reliability is defined as the like suppose reliability. It's T is stand for time period. Okay, reliability is like probability that T is greater than or equal to some time point small t. Okay, so that is also 1 minus probability that T is less than or equal to T, which is equal to 1 minus capital F of T. So reliability is related to the CDF of the distribution. Okay. And this means suppose a device like that means what? Suppose uh, suppose like any device or any component we have taken. Okay, and we need to calculate the reliability that it will function up to time point 50. Okay, so what is the probability that it will first of all it will survive up to time point 50, and at that point, at after the time point of 50, what is the probability that it will survive further? We will calculate this with the help of this, which is equal to the reliability of the product. Okay. Similarly, also there is one more concept like hazard rate. Hazard rate, which is instantaneous failure rate also. It can be denoted as like HT, which is equal to FT upon RT. Okay. This is the PDF and this is the reliability. This gives the failure rate, like the component or the equipment or the device is which which pattern is followed that day. Like suppose we have taken bulb, okay, and the failure rate of bulb is like exponential rate or not. Okay, so it is exponential actually. Okay, so bulbs fail exponential. It follows exponential distribution. So we mainly used to calculate the failure rate, instantaneous failure rate at time point t for any kind of equipments or devices. So hazard rate concept is also there. Okay, the formula is this. Actually, sir has already covered all the topics in a very vast way. I'm just trying to recall these are the things that already covered. Okay, and besides these, okay, I think yes. These are all the things that I remember that is covered. Okay, and there are lots of numerical is also there. So we will try to start numerical. Okay. If anyone have any doubt regarding anything, then please ask me directly. Okay, then we will start to solve the question. Question 1 is, in an book of 520 pages, 390 typographical errors occur. Assuming Poisson law for the number of error per pages, find the probability that a page will contain no error. Okay, so here we will given that like 390 error are there on 520 pages. Okay, so average or per page number of error per page is denoted as lambda. What is this? It is 390 upon 520, which is equal to, okay, which is equal to like 3 by 4. Okay, or 0.75. This is the value of lambda. and it follows Poisson law, means Poisson distribution. So, and also let random variable x is number of error per page. So it denotes the number of errors. Here the random variable x is the number of errors. Okay, so it follows only exponential, not exponential, it's Poisson distribution. That means it is e to the power minus lambda, lambda to the power x upon x factorial. Okay, now we need to calculate the probability that a page will contain no error. That is, we need to calculate the probability that x equal to 0. Okay, so it can be calculated like e to the power minus 0.75, 0.75 to the power 0 upon 0 factorial. Okay, and this can be calculated. Okay, I've already solved these questions actually, and this equals 1. So it is e to the power minus 0.75. Okay, you may solve this also. Okay, so the probability that there is no page. Suppose we have select a page randomly and no error on that page with the probability is this. Okay. Now question number 2 is like if x and y are independent Poisson variate such that probability at 1 equal to probability that x equal to 2 and y equal to 2 is equal to probability that y equal to 3. Then we need to calculate the variance of x minus 2y. Okay. Suppose here it is already given. It follows Poisson variate. That means let x follows Poisson lambda 1 and y follows Poisson lambda 2. Okay. Now it is given that probability that x equal to 1 equal to probability that x equal to 2. That means e to the power minus lambda 1 to the power x, it's 1 upon 1 factorial equal to e to the power minus lambda 1 to the power 2 upon 2 factorial. From here, this is cancel out and we can get lambda 1. Okay, 1 equal to lambda upon 2. This implies lambda 1 equal to 2. Okay. Similarly, we can calculate like probability that y equal to 3 equal to probability that y equal to 2. Okay. Then from here, e to the power minus lambda 2 to the power 2 upon 2 factorial equal to e to the power minus lambda 2 to the power 3 upon 3 factorial. It is already given. We just try to follow the step to solve this question. Okay, e to the power minus lambda cancel out, and then it is 1 upon 2 factorial equals lambda 2 upon 3 factorial. And from there, we have calculated 3 factorial upon 2, lambda 2 equal to 3. Okay, so we have lambda 1 and lambda 2. That is That is, X follows Poisson with 2 and Y follows Poisson with 3 parameter. Okay, now we need to calculate the variance of X minus 2Y. Okay, we need to calculate variance of X minus 2Y. So first, variance of X minus 2Y, it is also given here, like it is independent. There is no correlation in X and Y. So that means variance of X minus 2Y is variance of X plus 2 square, variance of Y, which is equal to variance of X plus 4 into variance of Y. So we need to calculate the variance of X and variance of Y. And since X follows Poisson 2, so exponential or not exponential, expected value of X is 2. Variance of X is also 2. And variance of Y equal to 3 and expected value of Y equal to 3. We don't need actually expectation because for Poisson process or Poisson variable, lambda is the mean as well as lambda is the variance. Okay. So variance of X minus 2Y equal to, it's 2 plus 4 into 3, which is equal to 2 plus 12, 14. Okay. Is it clear now? Okay. Now, third question. Like here, X is a uniformly distributed with mean 1 and variance 4 by 3. We need to calculate the value of probability that X is less than 0. Here we are given X follows uniform distribution with some parameter. We are not given the parameter. Let us assume it's AB. Okay. And then the PDF of uniform distribution is like 1 upon B minus A. We are given and mean equal to like B plus A upon 2 and variance of X is like B minus A whole square upon 12. It is given that mean equal to 1 and variance equal to 4 by 3 here. So from here, our aim is to calculate first like the PDF, and then with the help of PDF, we will calculate the probability. Okay, so from here, it's B plus A equal to 2, and from the variance part, it's B minus A whole square equal to K4, 16. This implies B minus A equal to plus minus 4. Okay. Since we have already know that here B is greater than A, this implies we have take the positive value. So we have a pair of question in two variables. Like first one is B plus A equal to 2, and the second one is B minus A equal to 4. Adding both, we get 6. This implies B equal to 3. And putting the value of B in, suppose this equation, we get A equal to 2 minus 3.
-1.
Uniform distribution. Okay. So it is now the PDF is 1 upon B minus A, which is equal to 1 by 4 for this. Okay. Now we need to calculate the probability that x is less than 0. Okay. So probability that x is less than 0 is defined as minus infinity to 0, which is equal to minus 1 to 0, 1 by 4 dx, which is equal to x minus 1 to infinity to 0, 1 minus 1, that is 1 by 4. Okay. So the probability that the random variable x is less than 0 is 1 by 4. Now, question is, a point x is chosen at random from the interval 0, 1 with the probability density function. We are given fx equal to 1, otherwise 0. The probability that the first decimal digit of x will be 3. Okay. The first decimal digit will be 3. That means the number is like 0.3 to 0.399 something. Okay. That means we need to calculate the probability that x lies within 0.3 to 0.4. Okay. This is equal to integration of 0.3 to 0.4 of dx, which is equal to x 0.3, 0.4, which is equal to 0.4 minus 0.3. It's a simple question, just a simple calculation. Okay. Now, question number 5. The lifetime of a bulb is exponentially, like here it is already given, exponential distributed. The lifetime of a bulb is exponentially distributed with mean 100 hours. The bulb remains switched on for exactly 4 hours every day, and the remain switched off the remaining time. What is the probability that the bulb stop working on or before the 25th day? Okay. Okay. So can anyone tell me how to proceed? Like it is given, suppose the random variable x is, so lifetime of bulbs. Okay. And it is the average value is this, the mean value is this. That is, if x follows exponential with lambda, and also here lambda equals 100 hours. Okay. I think it depends on which form we are going to use. Lambda to the power minus lambda. In that case, in this situation, mean equal to 1 by lambda, and this is equal to 100. This implies lambda equals 1 upon 100. Put this. To the power minus x by lambda. Here lambda. Okay. So both are the like used. If you use this form, then mean is this. If you use this form, then mean is this. Okay. So we are given like parameter value is 1 by 100. Okay. Now our function is like 1 by 100 e to the power minus x by 100. This is the PDF. Okay. Now our next aim is to calculate the probability that the bulb stop working on the 25th day. It is given that on each day the bulb is mainly used for 4 hours per day. So that means on 24th day, this is 25th day per day 4 hours. That is 100 hours. Okay. So we need to calculate the probability that X is stop working on or before. That is either less than or equal to 100 hours. So simply it is calculated by like this 0 to 100. So okay, lambda e to the power, not lambda, it's lambda. I've already calculated the value of lambda. So 1 by 100 e to the power minus x by 100 dx. It's 1 by 100. It is the integration now. E to the power minus x upon 100 divided by 1 by 100. Minus is there, 0 to 100. So it is cancel out, and then it is minus sign is there. So 0 cancel out 1 and 100 e to the power minus 1. That is 1 minus e to the power minus 1. Okay. Is it clear now? Here we have put the value of 100 and then 0 and solve this, we get this value. Okay, next question. X has a exponential distribution with the mean 1 by lambda. Okay, the mean is 1 by lambda. Then we need to find probability that x is greater than 3 given x is greater than 1. Okay, so we can solve this with two ways because it is exponential distribution and this form is given. So we may either use exponential or we may not solve with the help of conditional concept like probability that A given B equal to probability of hello. Can anyone confirm? Am I audible or not?
Sir, audible, sir.
Okay. Okay. Here we need to calculate like it is given x follows exponential with mean 1 by lambda. That means x follows exponential lambda. Okay. And we need to calculate the probability this x is greater than 3 given x is greater than 1. And we know that exponential distribution follows nevertheless property. So we may solve with the help of both concepts. Okay, now first we will try usual method. like e to the power lambda e to the power minus lambda. Okay. So probability that x is greater than 3 given x is greater than 1. We can write this like probability that x is greater than 3 intersection x is greater than 1. Probability that x is greater than 1. Okay. This can be written as like probability that x is greater than 3. Probability that x is greater than 1. Okay. So now, okay. Okay. Now integral 3 to infinity lambda e to the power minus lambda x dx divided by 1 to infinity lambda e to the power minus lambda x dx. Okay, we may take lambda as a common, e to the power minus lambda x divided by minus lambda e to infinity. Similarly, lambda e to the power minus lambda x divided by minus lambda 1 to infinity. Okay, lambda is cancelled out, and then e to the power minus lambda x, then we will put the limits. So we get e to the power minus 3 lambda and divided by e to the power minus lambda, which is solved, simplify as e to the power minus 2 lambda. Is it clear now? It's a simple process. We know the formula this, and we will solve the probability of the given values. Now again, we may write this, the same question. Okay.
How that probability of x greater than 3 intersection x greater than 1 is equal to probability of x greater than 3.
Yeah, you will, okay. Suppose this is value of 1, this is 2, this is 3. Okay, x is greater than 3, this quantity. Okay, x is greater than 1, not sorry, see, x is greater than 1, this, and x is greater than 3, this. Both have this portion common, x is greater than 3. So this intersection part will be written, can be written like this. Is it clear?
Okay, sir.
Okay. Okay. So now we can also solve this with the help of memoryless property. The same question. Our question is like, we need to solve probability that x is greater than 3 given x is greater than 1. Okay. So we may write like probability that x is greater than 2 plus 1 given x is greater than 1. And since memoryless property is what? X is greater than m plus n given x is greater than n, which is equal to probability that x is greater than m. So this can be written as probability that x is greater than 2. Clearly. Okay. Now probability that x is greater than 2 equal to 2 to infinity lambda e to the power minus lambda x here, which is equal to lambda e to the power minus lambda x upon minus of lambda, and it's 2 to infinity. So lambda will be cancelled out. Minus sign is there. That is 1. If we put this and then minus and e to the power minus 2 lambda. I think I have put something wrong. It's first 2 to the power ex minus. Okay, wait. How it comes out to be 1? It is 0, na? Okay. Is it correct? Because we put the value of e to the power minus lambda x is equal to infinity, then it becomes 0. So it's 0, and then minus minus become plus e to the power 2x. So probability that x is greater than 2 equal to e to the power minus 2 lambda. So from here, and with the help of memoryless property, with the help of both methods, we find the same answer. Okay. Is it clear? Okay, now next question. Let fx equal to this. Now, if fx is a PDF, then what is the value of k? Okay, and we know that if if fx equal is a PDF, then integral over the given range of x fx dx equal to 1. Okay, so we will use the same logic. Okay, I think it is greater than, not less than. Okay, it is typo actually. X is greater than 0 actually. Okay. So integral over 0 to infinity k e to the power minus x, x to the power minus 1 by 2 dx equal to 1. Okay, I think everyone know about the gamma function or not?
Yes, sir.
Okay, e to the power minus x, x to the power, it's 1 minus 1 by 2 dx equal to 1. Since like e to the power minus x and x to the power n minus.
Sir, I think there is some mistake. X to the power 1 minus 1 by 2 is equal to x to the power 1 by 2, na? But here x to the power minus 1 by 2.
Okay, it's minus 1 by 2 plus. Wait. Let me check. I think n minus 1. It's minus 1 by 2 is already there. So 1 minus 1 by. Okay. Sorry. It is already given like minus 1 by 2. Okay. So it can be written as like this, na? It's 1 by 2 minus 1. Okay. This is equal to actually gamma n. Okay. 0 to infinity. The gamma function is this. Suppose it is given in this form, e to the power minus x, x to the power n minus 1. It is equal to gamma n. Okay. So we can write this in gamma function form. And from here, the value of this is what? A times of gamma of half equal to 1. Also, gamma 1 by 2 equal to gamma of pi. It is already proved. No? It's already known values. Okay. So from here,
Gamma 1 by 2 is equal to root pi.
yes, it's root pi. It's root pi, na? Is it right? I think. Hello. I think gamma 1 by 2 equal to root pi.
Yeah.
Okay. Your voice is not clear. Okay. So from here, we may calculate the value of k equal to 1 upon root pi. And we need to calculate the value of k, which is equal to 1 upon root pi. This is well-known result actually, and this is the gamma function, which is already well defined. Okay. 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 Now next question is the gamma question, gamma related. X follows gamma distribution with parameter 2 and 1 by 2. Then calculate the value of probability x is greater than 4. Okay. So first thing is we need to write the PDF. It is, suppose it is alpha, it is beta. In that case, the PDF is beta to the power alpha upon gamma alpha, x to the power alpha minus 1, e to the power minus beta x. X is greater than 0 and alpha is beta also greater than 0 and already clear. So fx is equal to beta to the power alpha 1 by 2 to the power 2 divided by gamma alpha, it's gamma 2, x to the power 2 minus 1, e to the power minus x by 2 can be solved like this. 2 factorial, gamma 2 equal to 1 actually. So it is 1 by 4 e to the power minus x by 2 into x. So our PDF is this. We have marked this equation 1. So our PDF is given this. Now we need to calculate the probability that x is greater than 4. Simply 0, not 0, it's 4. No? 4 to infinity. And fx equal to, it's 1 by 4 e to the power minus x by 2 into x dx. Okay, but we need to now integrate the whole thing. Okay. And here it is already given. There are 2 components. So integration by parts 1 by 4. Now first function integration of second function. Okay. We've considered it first into second. So first function integration of second function is like this, x by 2, 1 by 2. It's 4 to infinity minus differentiation of first function, integration of second function, integration of second function, whole integral. Okay. So from here we can write like this. Okay, we will solve this. So this quantity comes out to be 1 by 4. 1 by 2 is already there. So it comes out to be e to the power 2 e to the power minus 2. Is it right now? Minus. Then
There is a mistake. We put a value of infinite, in place of x we put 4 and then infinity.
yes, yes. So that is why I have, okay. Okay, and because there is minus here, no, actually, there is minus here. So we may solve like this. Okay, first we put the value of 4. 4 into e to the power minus 2 and whole divided by 1 by 2 minus e to the power minus something 0. Okay. And it is now calculated as plus half. Minus sign here and minus sign here comes out to be plus half. And then again e to the power minus x by 2 upon minus of 1 by 2. It's 4 to infinity. Okay. And then it's 1 by 4. So it is 8 e to the power minus 2 from this quantity and plus half, and half is also there. It comes out to be minus 1. Okay, so minus 1, and we put the value of 4, so it into minus 4 by 2. We can directly write minus 2 minus and minus. It's plus, na? Okay, can anyone help me? I think it is plus, na? Because we put the value of x is infinity first. Okay, let me write again the whole thing. It is 1 by 4, 1 by 2. Then for infinity, it is 0.
So it's not 1 by 2, it's become 2 because 1 by 2 e to the power minus x by 2 upon minus 1 by 2. It's going to be multiplied.
Okay.
2 multiplied.
Sorry. It is 1 actually, because it is in denominator and it is in numerator. Okay. Now is it correct?
No, sir. I'm talking about in second line. It's not 1 by 2, it's 2. Plus 2.
Okay. Okay. From here, you say.
Yes, sir.
Okay. And then e to the power this. Up to this point, is it correct or not?
Yeah, it is correct.
It is correct, na? We will solve this. Now it is minus there, minus 1 by 2. And this, it comes out to be minus 4. Okay. And in this part, it comes out to, okay, let me check actually. I'm so confused. I don't know why. Okay. So it is 4. It is twice of this. I think I've already solved some mistake here. Let me check. E to the power minus 2. Okay, 4 times of e to the power minus 2. So where it is wrong? Can anyone help me with it?
Sir, here at that point it is correct. Minus 1 by 2 is going to denominator, it's become 4. And then we put the value of
it is 4, and the value of this is e to the power minus 2 clearly, na?
Sir, minus
And this minus
0
comes
minus.
out to be plus. Yes. Now it is
Plus,
correct.
Yeah,
Now it is correct.
Answer is 3 into e power minus 2. 8 plus 4, 12. 12 by 4 is 3. 3 into e power minus 2.
Yes, thank you. I'm a little confused. I don't know why actually. Okay, it is now up to this point, it is correct. So we will solve this like this. It's 1 by 4. It's 12 e to the power, which is comes out to be 3 e to the power minus 2. Is this the right answer? No? Actually, I have solved wrong. That is why I am confused.
Yes, sir.
Okay. Okay, thank you. Thank you very much. Okay, now question number 9. Here X follows beta distribution with parameter 4, 4. We need to calculate the expected value of X. Okay, so the P of beta is 1 upon beta mn, then it's x to the power m minus 1 minus x to the power n minus 1. Okay, here we are given m and n equal to 4. So the PDF is like this: 1 upon beta 4, 4, x to the power 3, 1 minus x to the power 3. Okay, is it right? And also, like beta function can be defined as not beta, it is defined as like this, na? Gamma m, gamma n, gamma mn equal to it's gamma n plus 1. Is it right? Or is it reciprocal? I think it is right. Okay, gamma m, gamma n upon gamma m plus n. Okay, so we need to calculate the expected value of x, and the expected value of x is 0 to 1. It's x into 1 upon beta 4, 4, x to the power 3, 1 minus x to the power 3 dx, which is written as is a constant to taken out from the integral side. Integral like 0 to 1, x to the power 4, 1 minus x to the power 3 dx. Is it correct up to this point?
Yeah.
Yes, I got it. We can again use like this actually. Okay, so this can be written power 5. Okay. Wait. Yes. This can be used as like we can write 4, 4. Okay, and it's 0, 1. We can write x to the power this and 1 minus this. Okay, and this whole quantity is equal to what? It's beta 5, 4. It's a beta function. Okay.
1 second,
So,
sir.
Yes.
Sir, 1
Yes.
second. In integration, 1 minus x whole cube is 1 minus x whole power 4 minus 1 divided by minus 1. Minus x is available. We have to differentiate this minus x. Differentiation of minus x
Actually,
is
no. It is an improper integral. Na? We are not able to differentiate. Na? So we have already known the beta function and gamma function in mathematics. We use the same logic or same concept because that is why we use this. Na? This value is equal to beta 5, 4. And in similar manner, we have also used the gamma function. Like suppose x follows gamma distribution.
Understood, sir. Thanks.
Okay, thank you. Okay, so this quantity, this integral quantity equal to beta 5, 4. Now it is beta 5, 4, beta function, and it is beta 4, 4. This can be solved with the help of this formula, which is equal to beta 5, 4. It's gamma 5, gamma 4 upon gamma 5 plus 4 into it's gamma 4 upon gamma 4 plus 4, which is equal to 8. We have also known that like gamma n plus 1 equal to n factorial. So from here on, we can write it's 4 factorial, 3 factorial upon 5 plus 4, 9 factorial. That's 9 gamma, that is 8 factorial. Multiplied by 7 factorial 3 factorial, 3 factorial. Now you can solve these, and it is equal to it's 4 by 8 or 1 by 2. After solving all these, you may get it as 1 by 2. That is, if x follows beta 4 4, then the expected value of this is 1 by 2. Okay. Okay. Now, 10th question, the percentage of impurities per batch in a certain chemical product is a random variable x that follows the beta distribution given by this. Okay. What is the probability that a randomly selected batch will have more than 25% impurities? It is already given, it follows distribution this, and we need to calculate that probability that it is greater than 25% impurities, like 1 by 4 or 0.25 probability. Okay, so we need to calculate this. So it is simple now. It's like 1 by 4 to 1, 6x 1 minus x dx, which is equal to 6. We have taken common, 0.25 to 1. We can write like x minus x square dx. From here on, we can write x square upon 2 factorial minus, not 2 factors, 2, x cube upon 3, 1, 1 by 2 minus 1 by 3 minus, okay, we may use 1 by 4 here, so that calculation may be a bit easy. So it's 1 by 16, 1 by 32 minus 64. Okay. Okay. And it's 1 upon 64 into 3. Na? Is it right? So it's 6. 1 by 2 minus 1 by 3 is what? 6. 3 1 by 6, or we can directly write. Okay, cool. Minus it is 64 into 3. So it is 6 minus 1 is equal to 6. 1 by 6 minus 5 upon 92. Again, we can write like this. It's 3 and 3, 33, no, I think. 32, 32. 32 minus 5 is 27 upon 32. Is it clear now? Is it simple actually? Just a calculation, simple. We need to calculate the probability x is greater than this. We can write like this and calculate this. Okay. Now, question number 11. Here, a system consists of several components connected in a series parallel with command flowing from node A to node B as described below. The number in the boxes denote the reliability. Hello. Hello, am I audible?
Yes, sir. Now it is audible.
Not, actually, there are some network issue. Why? But my college Wi-Fi is not properly working. Okay, is it visible then? Na? Okay. We are given this question. Okay, we need to calculate the reliability. Reliability is actually probability. Okay, so we need to calculate this, that how much reliable this system is. So for this purpose here, it is a combination of series as well as parallel. Okay, so the whole system works if either one of the three paths, suppose here it is given three paths, like first, second, and third. If any one of the paths will work, the whole system will work. Okay, so first we will calculate the resultant probability of each path. Okay, and after that, we will calculate the reliability of the whole system. So, like reliability of the first path. Okay, so it is what? Here there are three components, all are connected in series, and also we have assumption like this, na, ki all the systems, all the components are independent with each other. So it is clearly the reliability, the resultant reliability or the effective reliability. The resultant reliability, suppose it is R1. For R1 equal to what? 0.9 into 0.8. Hello? Yes? Yes? Anyone have any doubt? Okay.
0.612, sir.
Okay. What it comes out? 0.621. Yes. Correct. 0.612. This is the probability for path 1. Okay. This is the reliability of the path 1. So again, for path 2, it is what? It's 0.95 only, because there is only one component in that path. And in suppose third series, it's 0.9 into 0.85, which is equal to 0.976, 76, and something 5. Okay. Okay. So we have calculated the probability for the all three series combination. Path 1, path 2, path 3. Now, our aim is to calculate the reliability of the complete system. The whole system will work if at least one of the path or one of the series will work or function. Okay. For this purpose, we need to calculate, like, suppose path 1 will work. Okay. And 2 and 3 will not work. Suppose this is for complement. And path 1 will work, 2 will not work. So it is a very tedious task. So we will calculate simply, like we will calculate the probability that or reliability, direct reliability of the system. One minus, suppose all the paths not working, like R1, R2, R3. Okay, if all the three have not functioned, then the system will fail. Otherwise, the system will not fail. So in that case, it is 1 minus, it's 1 minus 0.612, 1 minus 0.95, and it's 1 minus 0.765. And from here, it's 1 minus 0.388 into 0.05. It's 0. It's 2. 235 is 1 minus 0.00559, and then the reliability of the system is 9954. That is, the whole system is reliable 99.99, sorry, 0.9954. Hence we can rely on this because it is a very huge reliability of the product. Okay. Now, question number 12. If x1 and x2 are IID uniform variate, then what is the distribution of maximum of x1 and x2? Also, sir has already give one formula for this type of question. Here, if xi follows uniform 0, 1 or I equal to 1 to n, then suppose the distribution of xr, it is for ordered form. Xr is for ordered. Okay, so this follows beta, and what is the value of this r? It's n minus r plus 1. Okay, this is the formula. Okay, these are the parameter of n and r. Okay, and r as the actually the rth order value, and n is the total sample size. Okay, so here we are given only 2 samples, and both follow this. So here we can write like x1 and x2 in ordered form like this. X1 and x2, where x2 is the largest value or greatest value, and x1 is the smallest value because there are only 2. So from here, we need to calculate the max of this. So that means max of x1 and x2 is actually x2. Okay, so from here and from here, we will find out that r equal to 2 and n equal to also 2. Okay, so like max of x1, x2 follows beta r this, which is equal to beta 2, 2 minus 2 plus 1, which is equal to beta 2, 1. So that is max of x1, x2 follows beta 2, 1. That is option C is the right one. Okay, sir has already proved this. You people may see this is the property. Like if xi follows this, then xr, the rth order statistic, follows the beta distribution with the parameter this. Okay. Okay. Now next question is, if x is a gamma variate with both shape and scale parameter equal to 1. Okay. Again the same question, like we will already discuss like this. Then which one of the following is the correct one? Okay. So since x follows gamma, alpha, beta, in case x follows this, then PDF of x is it's beta to the power alpha upon gamma alpha, x to the power alpha minus 1, e to the power minus beta x. You already know x is greater than 0, alpha and beta is greater than 0. So here we are given equal to 1, like alpha equal to beta equal to 1. That means fx equal to it's x, it's not x, it's only e to the power minus x. Okay, and this is nothing but exponential 1. So that means the first option is the correct one. Okay. Now, since it is exponential 1, that is this. So expected value of x is what? Integral over 0 to infinity x e to the power minus x. You may solve this, and we have already known that the exponential is this, then its value is 1. The expected value for lambda equal to 1 is 1. Okay. Also, the variance, we have also known that the variance of exponential distribution is 1 by lambda square. So it is also again 1. So option B is also correct. Option C is also correct. And yes, option D is also correct actually, because for exponential distribution, the mxt equal to 1 minus, we have already used x, so we write it x upon lambda. Okay, and here lambda equal to 1, so it is 1 minus x to the power minus 1. Here it is, we have considered here t actually, here x only. You may write t as well. Okay. Sorry, not t. It is t. Okay. So I have written something wrong here. Okay. So all the 4 option is correct. Actually, it is a property of the exponential distribution. If x is exponential, then mean, variance we have already discussed, and the MGF of this is expectation of e to the power tx. After solving, we get this. So all the 4 options are correct here. Okay. The next question is like, if mean and variance of a beta distribution are this and this, derive the PDF of x. Okay. Okay. So suppose x follows beta mn. In that case, fx equal to like 1 upon beta mn, and x to the power m minus 1, 1 minus x to the power n minus 1. Okay. Okay. Now we are given that mean and variance is this. For this, mean is m upon m plus n, which is equal to 2 by 5, and variance is something, I think it is some complicated form. Let me check what is the value for variance. It's mn upon m plus n square, and it is m plus n plus 1, and it is given as 6 upon 275. Again, this is the same question actually. Okay, we have 2 equations with 2 parameters or 2 variables. We need to solve this. So from here we can calculate like this. I've written right. Okay, it's 5m equal to 2m plus 2n. That means 5m, not 5m, it's 3m. 3m minus 2n equal to 0. Our first equation. Now second equation is complicated. Okay, we may do one thing, like we may substitute value from here. Okay, we may m equal to, it's 2 by 3, it's n equal to, from here we may write like this, like n equal to 3 by 2 m. Okay, so we substitute this value here. So it comes out to be like m into 3 by 2 m upon m plus 3 by 2 m whole square m plus 3 by 2 m plus 1 equal to 6 upon 275. From here onward, we will write like 3 by 2 m square upon it's 5 by 2. 5 by 2 m square, and it is 5 by 2 m plus 1 equal to 6 upon 275. It is simply just a calculation, just some complicated calculation. Now it is simple actually. So m square is in numerator and in also denominator, so it is cancel out. So we can write the whole thing like this. This quantity is cancel out. So it is 3 by 2 upon 25 upon 4, 5 by 2 m plus 1 equal to 6 upon 275. So it is right 5 by 2m plus 1 equal to 3 by 2 into 4 upon 25 multiply by 275 upon 6. Okay. Now it can be solved. A1 1 12 equal to 11 minus 1. This implies m equal to 10 into 2 upon 5, that equal to 4. Okay, so m equal to 4 we have got. And after putting the value of m equal to 4, we get n equal to 3 by 2 m, which is equal to 3 by 2 into 4, which is equal to 6. So the PDF is we need to calculate the PDF, na? PDF of x. So the PDF is it's 1 upon mn, beta mn, it's beta 46 x to the power m minus 1, that is 3 or 4 minus 1, 1 minus x to the power n minus 1, it is 5. So this is the required PDF. We are given mean and variance, and with the help of mean and variance, we will mainly evaluate the parameters. Okay. The similar type of question are also given in the assignment actually. Okay, now question number 15. Let the random variable x have the moment generating function mxt, which is equal to sorry. We are given mxt equal to like 1 minus 2 e to the power minus 2. Okay. So, okay, I think there is something mistake here also. It is minus 1 actually. Okay. It is minus 1 actually. It is minus 1. Okay. So it is actually what? 1 minus t 1 by 2 or minus 1. Okay. This is the actual may with the help of uniqueness, existence and uniqueness theorem of moment generating function. Here the random variable x actually follows exponential distribution with parameter this. which is half. Okay. So PDF is, we need to actually learn something like moment generating function and mean variance. So it's 1 by 2 e to the power minus x by 2. Okay. Now we need to calculate the probability that x is greater than 1. So probability that x is greater than 1, which is equal to 1 to infinity 1 by 2 to the power minus x by 2 to infinity. Okay. So it is 1 by 2 is already there. 0. 1 by 2 is also. So minus e to the power 1 by 2. And it's divided by 1 by 2 as well, because this quantity is there. So it comes out to be e to the power minus 1 by 2 or 1 by 2t. Is it right? No?
I think if we put minus infinity first,
minus 1 by 2,
Yeah.
we have to take a minus 1 by 2 outside. Minus 1 by 2, 1 by 2 will be cancelled. In the outside, minus 1 could be there. So minus of
Yes,
e power plus 1 by 2 is the answer. I think so.
If it is minus, actually the answer is right. No, actually. I think we got the same result because minus is already taken.
Oh, okay.
Hello?
Okay.
Yes.
okay, sir.
Okay then. And the next, okay. We have completed here actually. Okay, anyone want to ask anything? Or want to ask any question regarding this?
Sir, one request, sir.
Yes, yes.
Actually, I joined in the class sometime later. I didn't see first 8 problems. If you show that, I will take a screenshot.
Okay. I think all these contents are also shared with you, na? With all the people actually.
Okay, sir. Second problem. Next. Okay, sir. Actually,
Yes.
sir, I didn't take second page and fourth page. I didn't take page number
Second
2
and
and
fourth.
4.
Okay, this is the
Second and
fourth question. This is the fourth question actually.
Page number in first question. I have taken the first one. Second half I didn't take.
Okay, second one is this.
No, sir. It go next. First one.
Okay, you want
This
the
one. This one.
second part. Okay, you want solution as well actually. I just think you only want question.
Okay, sir.
Okay.
Uh,
Now the
this one.
again this one.
Okay, sir.
Okay.
Okay, sir.
Just try to solve with yourself first. Okay.
Okay, sir. I will try.
Okay. Okay. Anyone want to ask any question? If not, I think we should conclude here then. Okay, then let me
Sir, can
first
you
stop the.
explain the question related to reliability? Can you
First of
explain the
all,
question related to reliability once more? Sir?
reliability.
Hello.
Okay, I think it's question. Yes, yes,
Hello.
yes, yes. No, hello. Yes, yes, yes. I can understand what you want to ask. Let me. Okay, question number 11. I think you want to ask. Is it?
Yes, sir. Yes, sir.
Okay. Here, let's see. Here we need to actually calculate the reliability of the whole system, or we need to calculate the probability, or we need to calculate the probability that the system works. Okay. For this purpose, the system will work if and only if at least one of the paths will working properly. Okay. So there are three paths, and in each path there are certain number of components are there with their corresponding reliability. Okay, so here at path one there are three components with reliability or probability both are same. Okay, with reliability 0.9, 0.8 and 0.85. Okay, so if all the three components are working, then this whole path or whole series works. Okay, so we need to calculate the resultant effect of this for path one. Okay, resultant. In a similar manner, for path 2 also, we need to calculate the reliability. And here, since there is only one component with reliability 0.95, so for second as well. And in case of third series, okay, there are two components with reliability 0.9 and 0.85. Okay, so we will also evaluate the resultant reliability of the path third. Now our question is the number of boxes denote the reliabilities of those. Then what is the reliability of the complete system? Okay, so we need to calculate the reliability. So the whole system will work if at least one of the path will working properly. Okay, at least one of the path. So either it may possible that either first path will work. Okay, let me change the color of this. It may possible like either first series work or first path is working and second and third is not working. Okay, it may also possible that first may work, second may work, and third may not work. It may also possible that first may not work, second may not work, and the third path is working properly. Okay, so that means there are a lot of possibilities that the system will work. So we will calculate the probability or the reliability that none of the path will work. Actually, if all the three paths will not working, in that situation our system will not working. Okay, so we will write like this. Okay, and then we will calculate the value simply, and this is the answer. Is it correct?
Yes, sir, I got it. Yes.
Okay, good.
Yes, sir, I got it.
Thank you. Anyone else?
Sir, in assignment, eighth question, you have to give any hints, sir. Eighth and ninth questions.
In assignment what?
Eighth and ninth questions, you have to give any hint.
Eight. Okay, actually, first I'm not able to clearly understand what you ask. You are asking like question number 8 and 9 related. It is already given there.
In assignment, sir, assignment.
Okay, I don't have assignments question, so you need to ask the whole question, so I can help maybe.
You have to give any hint for that question.
So I don't have the question. No? You need to ask the question first.
Okay, okay, sir. A
Okay,
point R is.
Yes. Yes. Ask again.
The point R is chosen uniformly from the interval 0, comma A.
From 0 to?
A. Closed interval is given,
Okay, okay.
which divides the interval into two subintervals.
Okay. Actually, I
The
don't get.
probable
You wait. You may ask the question. Maybe ask your question in the YouTube section, comment section. I will answer there because I'm not clearly understand the question. That's why. Okay, I've already given my channel link here. You may take a
and
screenshot or this is the one, the last one.
okay.
Okay, capital, it's NPTEL.statistics. Okay, you may drop. I will upload this maybe today. Okay, so you may
Okay.
ask the question. I will definitely answer there.
Okay.
Okay, anyone else? Okay, then let me first stop the recording then.